Right now, over South America, there is a hole in the shield that protects this planet, and it has just split in two. Satellites flying through that patch of sky lose data and reboot themselves because the magnetic field that stops the sun from reaching us is thinner there than anywhere else on Earth. In 11 years, it grew by an area nearly half the size of Europe. But the hole is not the story. It is a symptom. Follow it down, past 1,800 miles of rock, and you reach a continent-sized structure nobody can identify, sitting on a core that appears to be turning backward. The ground beneath you is humming, and it has never stopped. And this planet has quietly started spinning faster, for reasons nobody can explain. If that unsettles you the way it unsettles me, hit like and subscribe to the Skylab because this story is nowhere near finished. Drop a comment and tell me where you're watching from, and whether you have ever heard something from the ground that you could not explain. Now, let's get into it. Part 1. The hole above South America. A satellite crosses over Brazil and its computer starts making mistakes. Not dramatic mistakes. A bit flips somewhere in a memory register. A sensor returns a value that cannot possibly be right. A subsystem reboots itself for no reason the flight software can identify. Then the spacecraft clears the region, and everything goes back to normal, and the log entry gets filed alongside thousands of others exactly like it. The reason those log entries all look alike is that they all happen in the same place. Engineers have known about that place for a long time, and they gave it a name that sounds far too polite for what it actually is. They call it the South Atlantic Anomaly. It sits over Brazil and it stretches east across the ocean towards southern Africa, and inside that zone, the magnetic field of this planet is weaker than it is anywhere else on Earth. Here is why that matters, in the simplest terms I can give you. Earth generates a magnetic field. That field does not stop at the surface. It reaches far out into space, tens of thousands of kilometers beyond the atmosphere, and it deflects the constant stream of charged particles pouring off the sun. Without it, those particles would arrive unimpeded. They would strike satellites, spacecraft, the upper atmosphere, and eventually us. The field is the reason this planet gets to have an atmosphere and an ocean and a biosphere at all, instead of the slow sand-blasted erosion that happened to Mars. Over one patch of the southern hemisphere, that field thins out, and when the field thins, something specific happens above it. Earth is surrounded by two donut-shaped regions of trapped charged particles called the Van Allen belts, held in place by the magnetic field itself. Where the field is strong, the inner belt sits comfortably high above the surface. Over the South Atlantic Anomaly, the field is weak enough that the inner belt sags downward, dipping to roughly 200 kilometers altitude. That is not an abstract number. 200 kilometers is low Earth orbit. It is where the International Space Station flies. It is where a substantial fraction of every satellite you depend on is currently circling. So spacecraft fly straight through it, every day, over and over. The practical consequences are documented in operations manuals, not in speculation. Satellites crossing the anomaly take elevated radiation doses. Onboard computers suffer what engineers call single-event upsets, where a single high-energy particle strikes a memory cell and flips a 1 to a 0. Instrument teams routinely power down sensitive hardware before a pass and bring it back up afterward. The Hubble Space Telescope has historically stopped taking ultraviolet observations while transiting the zone, because the detector simply cannot produce clean data inside it. The International Space Station crosses the anomaly on essentially every orbit, and periodic instrument resets and data dropouts are a normal part of life on board. Spacewalk timing takes it into account. Picture a force field with a soft spot. Everywhere else the shield holds at full strength. Over this one section of ocean and coastline it thins, the way ice thins over a spring that never quite lets a lake freeze solid. Now, we have talked about this before. If you were here for our video from July 17th, you already know the outline of the story. The shield is thinning, the anomaly is growing, and the field has been declining for as long as anyone has measured it. I'm not going to reteach all of that. What I want to do today is start there and then keep going, because the anomaly is not actually the story. The anomaly is a symptom, and when you follow the symptom down, it takes you somewhere that almost nobody talks about. But first, the part that changed. The European Space Agency operates a constellation of satellites called Swarm, 3 of them, flying in formation and doing nothing but measuring the magnetic field of this planet with extraordinary precision. They have now been doing that continuously for 11 years, from 2014 through 2025, and that 11-year record is the best resolved picture of Earth's magnetic field that any generation of human beings has ever possessed. Over those 11 years, the South Atlantic anomaly expanded by an area described as nearly half the size of continental Europe, roughly 2 million square miles, added in a decade to a weak spot in the thing that keeps radiation off this planet. The point of minimum intensity, the exact centre of the weakness, kept sliding westward, further out over the ocean, year after year. And then, starting around 2020, the satellites picked up something that was not in anyone's forecast. A region of the Atlantic southwest of Africa began weakening faster than the rest of the anomaly, not uniformly, not the way you would expect a single feature to behave if it were simply getting bigger. One part of it started coming apart faster than the other part, which brings us to the thing I actually wanted to tell you. The South Atlantic anomaly is no longer one anomaly. Picture a single shallow valley in a landscape, and now picture a ridge slowly rising through the middle of it, dividing that one valley into two separate basins. That is, as closely as I can describe it, what the satellite data has shown happening. What used to be a single connected zone of weakened field is dividing into two distinct minima, one centred off the coast of South America, one newer centre emerging to the southwest of Africa, and the two of them are not behaving the same way as each other. The African side is weakening faster. One of the geomagnetism researchers working with the swarm data put it about as plainly as a scientist is willing to. He said the South Atlantic anomaly is not just a single block, and that it is changing differently towards Africa than it is near South America. Read that again, because there is a lot packed into a calm sentence. It means the weak spot is not a single object. It means something is acting on one end of it that is not acting on the other end. And it means that whatever that something is, it is doing it on a timescale short enough that 11 years of satellite data can watch it happen. Down here on the surface you would never know. There is no storm. There is no light in the sky. Nothing in the anomaly produces a single effect that a human being standing underneath it could perceive with their own senses. It shows up only in instruments, in radiation counters, in dosimeters, in satellites filing the same error report from the same coordinates, again and again, forever. That is the part that gets under my skin. Not that it is dangerous. It mostly is not, at least not to you personally. It is that the largest structural change to the protective field of an entire planet in modern recorded history is happening completely silently, and almost nobody living underneath it has ever heard it mentioned. And here is where the story stops being about a hole in the sky. Scientists agree the field is thinning over the South Atlantic. They do not agree on why. The explanations divide roughly into two families, and both of them point downward. One family points at strange rock formations sitting more than 1,000 miles beneath the surface, distorting the field from below. The other points at changes in the flow of molten metal at the very centre of this planet. Both of those answers have the same uncomfortable property. To check either one, you have to go somewhere no human being has ever been, and no human being ever will go. Not to the bottom of the ocean, not to the deepest mine, past all of that, past the crust, down through nearly 2,000 miles of rock, to a boundary where solid stone meets a churning ocean of liquid iron. Because the field is made down there. And if the field is doing something strange, then something down there is doing something strange first. Part 2. What is pushing back against the field? Nearly 2,000 miles beneath your feet, the rock stops. Not gradually. There is a sharp, distinct boundary, about 2,900 kilometres down, roughly 1,800 miles, where the solid rock of the mantle ends and something else begins. Below that line sits a shell of liquid iron and nickel, thousands of kilometres thick, hot enough to be molten, under pressure that would crush anything we have ever built moving constantly. Geologists call that boundary the core mantle boundary, and it is the single most important interface on this planet that nobody ever talks about. Everything in this video eventually leads back to it. The liquid metal down there is not sitting still. It convects, the way a pot of soup convects, with hotter material rising and cooler material sinking. But it is doing that on a rotating planet, which means the Coriolis effect organises all that churning into columns and spirals, rather than letting it slosh randomly. Moving liquid metal carries electric current. Electric current generates a magnetic field. That field in turn acts back on the flowing metal. The whole self-sustaining arrangement is called the geodynamo, and it is the reason a compass needle points anywhere at all. So the field is not a fixed property of Earth, the way mass is. It is an output. It is the running result of a machine that is currently operating several thousand kilometers beneath the chair you are sitting in. Every eddy in that flow, every change in the pattern of those columns, eventually shows up as a change in the field we measure from space, which means the anomaly is a readout. It is telling us something about the machine. Here is what the readout says. In a well-behaved dipole field, the field lines emerge from one hemisphere, arc out through space, and re-enter in the other. Near the core mantle boundary, that means flux should be flowing outward from the core, over most of the southern hemisphere. Satellite data, extended downward using mathematical models of the field, lets researchers reconstruct roughly what the field looks like at that boundary. And underneath the South Atlantic anomaly, they find patches where it is doing the opposite. Instead of flowing out of the core, the field lines curve back down into it. These are called reverse flux patches. Think of a wide river flowing in one direction, with a few localized eddies spinning the other way. Where those reversed patches sit, they partially cancel the field above them. Stack a big enough patch under a big enough area, and the field measured at the surface and at satellite altitude comes out weaker, which is precisely what the anomaly is, and these patches move. Satellite records show at least one of them drifting slowly westward beneath Africa, dragging part of the weak zone along with it. That is not a metaphor. A structure in the flow of liquid metal at the base of the mantle is migrating, and the consequence of that migration is that spacecraft in orbit above the Atlantic Ocean start losing data in a slightly different place every year. I want you to sit with the strangeness of that for a second, because we skate past it too easily. We're using satellites, the same class of technology that watches hurricanes spin up and glaciers retreat, and we are pointing them straight down through 1,800 miles of solid rock to watch the weather in an ocean of molten iron that no eye will ever see. Nobody has ever observed the outer core directly. Nobody ever will. It is not a question of funding or engineering ambition. The deepest hole human beings have ever drilled into this planet went down about 12.25 kilometers, roughly 7.5 miles, before the rock got too hot and too plastic to keep the borehole open. The mantle alone is around 2,900 kilometers thick. We have scratched about 0.4% of the way to the core, and that took 20 years and a Cold War's worth of motivation. So everything we know about the deep interior, we know the way a doctor knows what an unopened body looks like. We listen. We measure how waves pass through. We watch what leaks out. There is one more piece of the readout worth putting on the table before we go looking for a cause, because it puts the anomaly in proportion. The whole field globally is getting weaker. Carl Friedrich Gauss set up the first systematic magnetic observatories in the 1830s, which gives us close to 2 centuries of instrumental record, and across that span the strength of the planet's main dipole field has declined by something like 9 or 10%. Push further back using archaeomagnetism. The field directions and intensities frozen into fired clay, kiln bricks, hearths, and volcanic rock, and the reconstructions suggest a decline closer to 30% over the last 3,000 years. I want to flag that second number honestly, because it gets quoted everywhere as though it came off an instrument. It did not. It is a reconstruction, assembled from scattered archaeological material with real uncertainty attached, and it is not the same class of evidence as 11 years of satellite measurement. It is still the best estimate we have, and the direction of travel is not in dispute. The field is coming down. There is also a pattern to how the whole thing moves that has been known since the 17th century. Features in the field drift steadily westward, mirroring the flow of the metal generating them. Geophysicists call this family of slow changes secular variation, a wonderfully unexciting name for the ongoing rearrangement of a planetary shield. Everything we have discussed so far is secular variation. The question is whether it is ordinary secular variation, and what is leaking out right now is a message. The splitting of the South Atlantic anomaly into 2 separate weak points is not a random glitch in the sky. It is a signal that has travelled up through nearly 2,000 miles of solid rock to tell us that the pattern of flow in the core has changed in a way the models did not fully anticipate. The obvious next question is what changed it? And when researchers went looking for something at the core mantle boundary that might be able to disturb the flow underneath Africa, they found something. They found it decades ago, actually. It is one of the two largest structures inside this planet. It sits right where you would want it to sit if you were looking for a culprit, and after more than 30 years of study, we still do not know what it is made of. Part 3. Tuzo and Jason. There is an object beneath Africa roughly the size of a continent, and it does not have a satisfying explanation. Start with how we know it is there, because the method is genuinely elegant. When a large earthquake happens anywhere on Earth, it sends seismic waves through the entire planet, not just around the surface. Those waves travel through the deep interior and come out the other side where seismometers record them. The speed at which they travel depends on the properties of whatever they pass through: density, temperature, composition, rigidity. Faster through cold, stiff rock, slower through hot, soft rock. Same principle as sound moving at different speeds through air and water and steel. Collect enough earthquakes, recorded at enough stations, over enough decades, and you can invert all those travel times into a three-dimensional map of the inside of the Earth. The technique is called seismic tomography, and it is the closest thing we have to a CT scan of the planet. When that scan is run, two enormous regions light up at the very bottom of the mantle, right on top of the core. In both of them, shear waves travel roughly 1 to 3% slower than they should. One sits under Africa, the other sits under the Pacific Ocean, almost exactly on the opposite side of the world. The formal name for them is large, low shear velocity provinces, which is a phrase built by committee. The informal names are better. The African one is called Tuzo. The Pacific one is called Jason. They are named after two of the geologists who worked out how this planet's interior actually behaves. The scale is difficult to hold in your head. Each of these structures is thousands of kilometers across, genuinely continent-sized. The African one rises as much as 1,000 kilometers above the core mantle boundary, which is to say it is a third of the way up through the mantle from the bottom. Between them, the two structures cover something on the order of a third of the entire surface of Earth's core. Imagine two enormous mismatched patches sewn onto opposite sides of a sphere, and the sphere is the core of this planet. Nobody has ever touched one. Nobody is going to. The Kola borehole reached 7.5 miles. Tuzo begins about 1,100 miles down. Every single thing we know about these structures we know from listening to earthquakes. Now, why does this matter to a video that started with satellites glitching over Brazil? Because when researchers studying the South Atlantic anomaly looked at where Tuzo actually sits, they found it lying almost directly beneath the weakest point in this planet's magnetic field. That is not treated as coincidence, and there is published work behind the connection rather than just a map overlay. Tuzo is denser, hotter, and chemically different from the mantle rock around it. It sits directly on the liquid outer core, and a structure like that, parked at the boundary, changes how heat escapes the core underneath it, which changes the pattern of convection in the liquid metal there, which changes the field that convection generates. Think about a boulder sitting on the bed of a fast river. The water directly above and behind the boulder does not flow the way water over a smooth bed flows. It swirls, it separates, it forms standing eddies that persist as long as the boulder is there. Now scale that up to a boulder the size of a continent, sitting in an ocean of liquid iron, and let it run for 100 million years. The eddies it produces are not local disturbances. They are the reason there is a permanent weak patch in the magnetic field of an entire planet, and they are very likely the reason the reversed flux patches we talked about a moment ago are sitting exactly where they are. The structure at the bottom of the mantle is shaping the field at the top of the atmosphere. That is the chain. That is what I meant when I said the anomaly is a symptom. So what are these things? This is the part where I have to be honest with you rather than tidy. Researchers genuinely disagree, and they have been disagreeing since the structures were first mapped. One family of explanations says they are graveyards. Over hundreds of millions of years, plate tectonics drags slabs of old ocean floor down into the mantle at subduction zones. Those slabs are cold and dense, and they sink. Some of them appear to sink all the way, piling up at the very bottom, accumulating over geological time into vast heaps of ancient seafloor. Detailed models tracking the deep interior over the last billion years suggest the Pacific structure has been continuously fed by fresh material sinking down this way, while the African one is older, more thoroughly mixed, and assembled over a much longer span. The other family says they are original equipment, leftover material from the violent early history of this planet, possibly, in one version, remnants of the impactor that struck the young Earth and produced the Moon, that sank to the bottom of the mantle billions of years ago and simply never moved again. Sediment at the bottom of a lake that nothing has ever disturbed. There is no way to test either idea directly. You cannot go and get a sample. One research team studying the problem summarized the state of knowledge with a bluntness I appreciate. The structures are, in their word, mysterious. The scans confirm they are there. Almost nothing else about them is firmly established, and they are not identical to each other, which makes the puzzle worse rather than better. Tuzo rises significantly higher above the core boundary than Jason does, and appears to have a lower density, which may make it less stable over long stretches of geological time. Two structures, the same class of object, on opposite sides of the same planet, behaving differently. There is one more detail that turns this from a curiosity into something with consequences at the surface. When researchers mapped where Earth's volcanic hotspots sit, not the ones along plate boundaries, but the deep ones, the ones that punch up through the middle of plates, both active today and traced through the geological record, they cluster suspiciously close to the margins of these two structures, which suggests that whatever Tuzo and Jason are, they are influencing volcanic activity nearly 2,000 miles above themselves. It is worth spelling out what a 1 to 3% slowdown in wave speed actually implies, because on paper it sounds trivial. Seismic waves crossing the deep mantle are moving at something like 7 kilometers every second. Shaving 1 to 3% off that, consistently, across a region thousands of kilometers wide, is an enormous amount of accumulated delay, and it is not something you get from a small variation in temperature alone. A hot patch of ordinary mantle rock would slow waves a little. Slowing them this much over a region this large, with the sharp edges that the tomography shows, points to material that is chemically different from everything around it. A distinct substance, not just a warm spot. That distinction is the entire reason the debate over their origin exists. If Tuzo were simply hot mantle, nobody would be arguing about impactor remnants. The sharpness of the edges matters too. If these were slowly dispersing plumes of warm rock, their boundaries would be smeared out over hundreds of kilometers. Instead, some studies find surprisingly steep margins, which implies the material inside is dense enough to resist being mixed into the mantle churning around it. Whatever these things are made of, they are heavy, they are stubborn, and they have stayed put while the surface above them rearranged its continents several times over. So we have a structure we cannot identify, sitting on a core we cannot see, apparently steering both the magnetic field and the volcanoes, and it is not even the strangest thing down there. Because underneath Tuzo, past the liquid metal, right at the centre of this planet, there is a solid ball of iron. And a growing body of evidence says that ball has stopped, turned around, and started going the other way. Part 4. The ball of iron that turned around. Picture a sphere of solid iron about 70% the radius of the Moon, sitting at the centre of the Earth. That is not a metaphor for anything. That is the inner core, roughly 1,220 kilometers in radius, solid despite being hotter than the surface of the Sun, kept solid by pressure alone. Its boundary sits about 5,150 kilometers down, around 3,200 miles beneath the place where you're standing. Here is the crucial fact about it. The inner core is not welded to the rest of the planet. It is a solid ball suspended in a liquid one. The flowing metal of the outer core pushes on it electromagnetically. The mass of the mantle above tugs on it gravitationally. Between those two competing hands, the inner core is free to rotate at a slightly different rate than everything above it. For decades, the consensus was that it rotated slightly faster. A spinning top nested inside a slightly slower shell, gradually gaining ground, lapping the planet around it over the course of centuries. Now, how would you ever check that? You cannot see it. You cannot put an instrument on it. The answer that seismologists came up with is one of my favourite pieces of scientific improvisation in any field. You use earthquakes. Specifically, you use pairs of earthquakes that happen in nearly the same place, years apart. Fault zones repeat themselves. The same patch of rock can rupture again decades later in almost exactly the same way. When that happens, the two events send out nearly identical seismic waves. Seismologists call them waveform doublets. Now send those waves through the centre of the Earth and record them at a station on the far side. If the inner core is locked to the rest of the planet, the waves from both earthquakes cross the same material in the same orientation, and the recordings should look essentially identical. If the inner core has rotated even slightly between the two events, the second set of waves crosses a slightly different piece of it, and the recording changes. The recordings change. They have been changing for as long as anyone has been looking. That drift is the fingerprint of a solid ball of iron turning at its own pace, 3,000 miles down. In 2023, 2 researchers at Peking University published a study in the journal Nature Geoscience that changed the picture. They used waveform doublets from earthquakes in the South Sandwich Islands, in the far South Atlantic, recorded at stations in Kyrgyzstan, with gaps between paired events ranging from about 6 to 17 years. What they found was that around 2009 the differences stopped. The travel times converged. Whatever extra speed the inner core had been carrying relative to the mantle had gone to zero. For a moment, the ball of iron at the centre of this planet was turning at exactly the same rate as the ground under your feet. Then the differences came back, with the sign flipped. The core was no longer running ahead, it was falling behind. Their interpretation was that this is part of a cycle, something on the order of 70 years long, swinging from faster than the mantle to matched to slower and eventually back again. And if that cycle is real, it means the inner core did this once before, sometime in the early 1970s, and not one person on the surface of the Earth noticed a thing. A year later, in 2024, a team led by a seismologist at the University of Southern California published in Nature with a much larger dataset, on the order of 121 pairs of repeating earthquakes from the same South Sandwich Island source region, spanning more than 3 decades. Same conclusion. The inner core decelerated, matched pace, and began backtracking. The lead researcher's summary of the result was not hedged. He said they had been arguing about this for 20 years, and that this evidence nails it down. Let me give you the comparison that makes it click. Imagine 2 runners on a circular track, one in the inside lane, one in the outside lane. For decades, the inside runner gains, slowly lapping ahead. Then the inside runner slows to match, then keeps slowing until relative to the runner beside them, they are drifting backward. That backward drift is what seismologists are now seeing in the deep Earth. The inner core has not reversed its rotation in any absolute sense. It still turns with the planet once a day like everything else. What has reversed is its motion relative to the rest of us. What causes it? The best current answer is that the swirling liquid metal of the outer core and the gravitational pull of the mantle above are both tugging on the solid ball between them, nudging its spin one way and then the other over the span of decades. 2 hands on the same object taking turns, and what does it mean for you? On the surface, day to day, almost nothing. You will never feel this. No instrument in your house could ever detect it. But it is not disconnected, and this is the whole reason it belongs in this story. The inner core's motion is coupled to the outer core's convection. The outer core's convection is what generates the magnetic field. So a ball of iron drifting backward 3,000 miles beneath your house is not a separate curiosity from the hole in the shield over South America. They are the same machine, reported by 2 different instruments. Now I have to give you the honest caveat, because this channel does not do the version where every finding is settled. That 2023 study used 7 waveform doublets. The 2024 study used around 121 event pairs. Those are small numbers by the standards of most sciences. What makes the result credible is not sample size. It is that 2 independent teams using different data and different methods arrived at the same conclusion. And the 70-year cycle in particular rests on roughly 2 turning points, which is a thin basis for declaring a period. The real test is still ahead of us. If the cycle is genuine, the core should decelerate again and turn back within a predictable window. Nobody has watched a full cycle. We have only ever seen pieces of one. So that is the chain. Downward. A weak spot in the sky above Brazil. Reversed flux at the top of the core. A continent-sized structure of unknown composition sitting on top of that. A solid iron ball at the centre turning the wrong way. Now we go back up. Because the same machine that produced all of that is also currently moving something that every ship, every aircraft, and every phone on this planet quietly depends on. And in the last few years it did something that nobody predicted and nobody has explained. Part 5. The pole that sprinted, then braked. Every compass on this planet is pointing at a moving target, and for about 30 years that target was sprinting. Most of us were taught that the North Pole sits in one fixed place at the top of the world. That is true of the geographic pole. The point where the axis this planet spins around intersects the surface. It does not move in any way that matters to a human lifetime. But the magnetic North Pole, the thing a compass needle actually seeks, is a different object entirely, and it has never once held still. The first person to physically stand on it was James Clark Ross in 1831 in the Canadian Arctic on the Boothia Peninsula. That is our 0 point, the first hard fix on where magnetic north actually was. For the next century and a half it crept, less than 10 kilometres a year, wandering around the Canadian Arctic archipelago, a drift so slow that it barely mattered outside of specialist navigation. A sailor in 1890 and a sailor in 1950 were working with essentially the same correction. Then, sometime around the 1990s, it hit the accelerator. The pole's speed climbed to something in the range of 50 to 60 kilometres a year, roughly 30 to 37 miles, and it stopped wandering. It picked a direction and committed to it, out of Canada, across the Arctic Ocean, towards Siberia. It is now in the central Arctic Ocean, in territory no instrument has ever recorded it occupying before, and after nearly 2 centuries of continuous drift, it crossed a genuine milestone. Magnetic north is now officially closer to Russia than it is to Canada. Picture a marble sitting near the bottom of a shallow bowl, barely moving for a century and a half. Then someone tilts the bowl, and the marble takes off. Researchers are still arguing about what tilted it. The best current answer, again, is that this is not happening at the surface. 2 decades of satellite data point to something like a tug-of-war going on at the top of the core, roughly 1,800 miles down, between 2 intense lobes of magnetic flux. One of them sits under Canada, the other sits under Siberia. For most of the 20th century, the Canadian lobe was the stronger of the two, and it held the pole nearby. Then researchers found that changes in the flow of molten metal between about 1970 and 1999 stretched the Canadian lobe out and weakened it. As it lost its grip, the Siberian lobe effectively won the contest and started dragging the pole east. Notice what that means. The pole did not move because something new appeared in Siberia. It moved because something in Canada let go. The winner of that tug-of-war was decided by a change in the flow pattern of liquid iron in the same core that is currently producing reversed flux patches under the Atlantic and hosting a solid ball that has begun turning backward. This is not a second story. It is the same story with a different readout. Now this matters far outside geophysics, and here is exactly how. The position of magnetic north feeds directly into something called the World Magnetic Model. It is maintained jointly by the National Centres for Environmental Information at the National Oceanic and Atmospheric Administration in the United States and the British Geological Survey in the United Kingdom, and it is the official reference for where the magnetic field is pointing at every location on the planet. Military and civilian aviation use it. Naval and commercial shipping use it. Submarines use it, because underwater you cannot see satellites. The compass app on your phone uses it, and so does every piece of navigation software that needs to reconcile a magnetic heading with a map. That model has to be revised on a schedule, and if the field moves faster than the revision schedule anticipated, errors quietly creep in. Not dramatic errors, the kind that put a heading a few degrees off, which is nothing on a short hop and quite a lot across an ocean. The most recent version, the 2025 model, was released with roughly 10 times the spatial resolution of previous versions. Not because anyone wanted a nicer map, but because the field is moving fast enough that the old resolution was becoming inadequate. There is a detail in the history of that model that tells you how quickly things were moving. The World Magnetic Model is normally revised on a 5-year cycle. A new edition, valid for the following 5 years, and everything in between is handled by the model's own predictive terms. That schedule held for decades. Then, at the end of the 2010s, the pole outran the prediction badly enough that the agencies responsible issued an out-of-cycle update, ahead of schedule, because the errors accumulating at high latitudes had grown past the acceptable threshold before the edition had even finished its term. That is an unglamorous piece of administrative housekeeping, and it is also one of the clearest signals in this entire story. The planet moved faster than the paperwork allowed for, and then, having spent 30 years telling everyone that the pole was accelerating, the researchers watching it had to report the opposite. It slowed down. From that frantic 50-odd kilometres a year, it has dropped back to something closer to 35. and the people who study the deep core describe this as the largest deceleration in pole speed ever measured. I want to be clear about why that is more interesting than the acceleration was. An accelerating pole is a system doing something dramatic. A pole that accelerates for 30 years and then abruptly puts on the brakes is a system doing something structured, something with a cause that came and went, and nobody can currently say what it was. One geomagnetic researcher summarized the position about as honestly as it can be summarized. He said it could speed back up, or it could keep slowing down, and right now the only honest answer is that we are watching in real time. That is the sentence that keeps coming back in this story. We are watching in real time. Not modeling, not predicting. Watching. So the field is thinning in one place, splitting in two, and the pole it defines has sprinted a couple of thousand kilometers and then stopped sprinting for reasons unknown. The obvious question, the one everybody asks the moment they hear any of this, is whether this is the beginning of the big one, whether the field is about to flip. And the honest answer to that requires a much longer memory than 2 centuries. Part 6. 183 times before. North has not always been north. Earth's magnetic field has completely swapped polarity. North Pole becoming South Pole and back again, at least 183 times in the last 83 million years alone. Push the record back further, and several hundred more reversals show up in the preceding 160 million years. During certain particularly chaotic stretches, the field flipped as often as 26 times per million years, which is more than 5 times the pace seen over the last 10 million. The way we read that record is one of the most satisfying pieces of geology there is. Molten rock rises along mid-ocean ridges and cools into solid basalt. That basalt contains tiny magnetic mineral grains, and while the rock is still hot, those grains are free to swing around and align with whatever direction the Earth's field is pointing. Then the rock cools past a threshold temperature, and the grains lock in place permanently. A compass needle frozen in stone, holding the orientation it had on the day it solidified. The seafloor spreads outward from those ridges. Rock formed today records today's field direction. Rock a few kilometers away formed 1 million years ago and records the field direction 1 million years ago. Sail across an ocean towing a magnetometer, and you read the record like pages in an enormous stone notebook. And what those pages show is stripe after stripe of alternating polarity, symmetrical on both sides of the ridge. It was that observation, in the 1960s, that turned continental drift from a fringe idea into plate tectonics. The last full reversal is called the Brunhes-Matuyama, and it happened roughly 780,000 years ago, long before modern humans. Homo erectus was around. Nobody wrote anything down. Here is the part that surprised researchers most recently. Analysis of sediment layers, which record the field continuously, rather than in discrete volcanic snapshots, indicates that the last reversal did not happen quickly. It dragged on for at least 22,000 years, several times longer than earlier estimates. Not a sudden flip overnight, a long, staggering U-turn, the field weakening dramatically, wobbling unpredictably, sometimes developing multiple weak poles at odd locations around the globe, briefly stabilizing, then finally settling into its new orientation. 22,000 years. For comparison, all of recorded human history is somewhere around 5,000. A civilization could rise and fall entirely inside the transitional phase of a magnetic reversal, and never once experience a stable field. Since that last full reversal, the field has tried and failed about 15 times. Those failed attempts are called excursions, episodes where the field weakened dramatically and started drifting toward a flip without ever completing one. The best documented of them is the Lashom excursion, roughly 41,000 years ago, during which field strength dropped to a small fraction of normal for a few centuries before recovering. Our own species was alive and painting on cave walls through it. There is a second, independent way to read those weak field episodes, and it is worth knowing because it does not depend on rocks at all. When the magnetic shield weakens, more cosmic rays reach the upper atmosphere. Cosmic rays striking atoms up there manufacture radioactive isotopes, carbon-14, beryllium-10, which then rain down and get locked into ice cores, into ocean sediment, into the growth rings of trees. So a weak field interval leaves a chemical signature in completely unrelated archives, a spike in cosmogenic isotopes at the same moment in ice from Greenland and Antarctica, and in sediment from the Pacific floor. When the magnetic record from volcanic rock and the isotope record from an ice core agree on the timing of the same event, that is about as close to independent confirmation as this field gets. The Lasham is dated that way, and it is why we can put a number on how far the field actually fell rather than just noting that it wobbled. And that brings me to the most important correction I can offer you about this entire subject, because it is the detail that the alarming version always leaves out. The field does not go to zero. During a reversal, the dipole, the clean, simple bar magnet component that gives you a north and a south, weakens dramatically. But the field does not switch off. It becomes multipolar, several weaker poles scattered at strange latitudes, a messier and more complicated shield rather than an absent one. Charged particles still get deflected. It is a worse shield. It is not no shield. So, is the South Atlantic anomaly the opening act of the next one? Genuinely, nobody knows, and anyone who tells you otherwise is selling something. The case for yes is real. The field is weakening, the anomaly is growing and splitting, and reversed flux patches at the core mantle boundary are exactly the kind of structure that grows during a reversal. The case for no is equally real. The field has weakened and recovered many times without flipping. Roughly 15 excursions have failed to complete since the last reversal, and the current rate of decline sits within the range of ordinary secular variation. We have a couple of 100 years of instrumental data on a process that takes tens of thousands of years to unfold. That is like watching 4 seconds of a film and being asked to describe the plot. What I can tell you with confidence is what a weakening field actually costs, because that part is not speculative. It is technological, not existential. More radiation reaching satellites, more single-event upsets in spacecraft electronics, higher doses on polar flight routes, geomagnetic storms from the sun reaching deeper and doing more damage to power grids and pipelines than the same storm would have done a century ago. Life on this planet has survived every reversal in its history, including our own lineage. Our infrastructure has never been tested by one, and underneath all of it sits the same unsettling fact. Every part of this, the anomaly, the pole, the reversals, is an output of a machine we cannot see, whose behaviour we are inferring from the outside, which is why it is worth knowing that the machine has recently started doing something else, something you could, in principle, measure with a good enough clock. Part 7. The Day That Was Too Short. For essentially the entire history of this planet, one fact has held steady. Earth has been slowing down. 100 million years ago, a day lasted about 23 hours. Go back further and it gets shorter still. The cause is well understood and not remotely controversial. The moon raises tides in our oceans. Those tidal bulges are dragged slightly ahead of the moon by Earth's rotation. The gravitational pull between the bulge and the moon acts as a brake on the spin and as an accelerator on the moon's orbit. We lose rotational energy. The moon drifts away from us by about 3.8 centimeters a year, a figure measured directly by bouncing lasers off reflectors left on the lunar surface. This is the most reliable long-term trend in the physics of this planet's motion. And then, starting around 2020, it reversed. Earth began spinning faster. The change is tiny. We are talking about a difference of 1 or 2 milliseconds in the length of a day, far less than the blink of an eye, utterly imperceptible to anything living. But we have atomic clocks. We have satellite laser ranging and radio observations of distant quasars that let us measure Earth's rotation with a precision that is genuinely difficult to overstate. And on those instruments, the change is unmistakable. On the 5th of July, 2024, Earth completed a full rotation about 1.66 milliseconds faster than the standard 24 hours. That was the shortest day ever recorded since scientists began keeping time with atomic clocks nearly 70 years ago. The following summer, in 2025, that record was very nearly broken again, more than once, on the 9th of July, and then again on the 22nd of July and the 5th of August, all of them clustering on dates tied to the moon's position relative to Earth's equator. Here is the physics of why any planet's spin rate can change. It is the same principle that governs a figure skater. A skater spinning with arms outstretched pulls those arms in tight to the body and speeds up, without pushing off anything, because the total angular momentum has to be conserved, and bringing mass closer to the axis means the rotation has to compensate. Move mass on Earth closer to the spin axis, and the planet turns fractionally faster. Spread mass outward toward the equator, and it turns fractionally slower. That is why this is such a strange result. Because we know exactly what the biggest ongoing mass redistribution on this planet is, and it points the wrong way. Ice is melting at the poles. That water flows into the world's oceans and spreads across the whole surface, which is mass moving away from the axis, toward the equator, the skater spreading her arms. A major study published in the journal Nature confirmed that climate change and melting ice caps have been measurably dragging on Earth's rotation over recent decades, slowing it down. So melting ice is slowing the planet, tidal breaking from the moon is slowing the planet, and the planet is speeding up anyway. Something is overpowering both of them. One geophysicist studying the trend described the situation as unprecedented. And it is notable enough that timekeepers are now seriously discussing something that has never happened in the entire history of coordinated global time, a negative leap second. You may know about ordinary leap seconds. Because Earth's rotation is slightly irregular and atomic time is not, an extra second gets inserted into global clocks every few years to keep the two in step. 27 of them have been added since 1972. Every single one has been an addition, because until now the planet has always been running slow. A negative leap second is the reverse. You would subtract a second from global clocks, skip from 57 to 58, straight to 0. It has never been done. Every timekeeping system, every financial network, every satellite constellation and telecommunications backbone on Earth has code in it that handles the insertion of an extra second, and a great deal of that code has never once been tested against the removal of one. The current estimate is that it might be needed as soon as 2029. So what is actually speeding us up? The honest answer is that nobody is certain. The leading suspicion points to the same place everything else in this video has pointed, the core. Shifts in the flow of molten metal deep inside the planet redistribute mass, and the core and mantle exchange angular momentum with each other on decade timescales. Speed up the crust a fraction and you get exactly this. It ties the spin anomaly to the field anomaly to the pole anomaly under one mechanism, which is elegant and which is also exactly the kind of elegance you should be suspicious of. It remains a hypothesis. It has not been demonstrated. Sit with the position we are actually in. Every satellite in orbit, every navigation system, every high-precision timing network on this planet depends on knowing exactly how fast the ground is turning. And the honest answer from the people studying it hardest is that the ground under your feet recently started turning a little faster, and we do not know why. And the length of the day is not the only thing about this planet's rotation that has quietly gone strange. There is a wobble in how Earth turns that was discovered before the invention of the aeroplane. It has been running continuously ever since, except that a few years ago it very nearly stopped. Part 8. The wobble that stopped. Earth does not spin cleanly. The axis it turns around does not stay pinned to one exact point on the surface. It traces a small, irregular circle, drifting by several meters over the course of a year, in a motion astronomers call polar motion. It has been tracked for well over a century because it has to be. Every precise astronomical observation, every satellite orbit determination, every high-accuracy positioning system needs to know where the poles actually are at a given moment, not where they are supposed to be. One component of that motion carries a name from 1891. An amateur astronomer named Seth Carlo Chandler noticed that the stars appeared to sit slightly off from where a perfectly stable spin axis would place them, and that the discrepancy repeated on a cycle of about 433 days. It became known as the Chandler wobble, and for a long time nobody could explain why it existed at all. It is a free oscillation, a natural resonance of a slightly non-spherical, slightly elastic planet, and left alone, friction inside the Earth should damp it out within a few decades. It has not damped out. Something keeps re-exciting it, which means something keeps feeding energy into the wobble of an entire planet. Then, after 2015, it nearly disappeared. Measurements from the international service that tracks Earth's rotation showed the amplitude of the Chandler wobble collapsing to less than half its usual size. By 2017, essentially only the annual component of polar motion remained visible in the records. A 433-day rocking motion that had been running continuously since before anyone had photographed it went quiet. A study published in September of 2025 traced the cause. the analysis found that the strongest excitation at the Chandler frequency occurred in 2011 and 2012, and that the timing of that excitation is what set up the later collapse. Behind it sat a massive climate event, the powerful La Niña of 2010 and 2011, which shifted enormous volumes of water and atmospheric mass around the globe, most visibly by dumping historic rainfall onto Australia, and temporarily pulling enough water out of the oceans to register as a measurable dip in global sea level. Think of a spinning top that has kept a steady, familiar wobble for over a century, and then smooths out, almost stopping its characteristic rocking, triggered by rain falling on the other side of the world. The only comparable reduction in the historical record happened between about 1925 and 1940, when the wobble's amplitude dropped and its phase shifted abruptly. It came back after that. Whether it comes back this time is an open question, and it is one of the easiest things on this entire list for you to go and check yourself. Because polar motion data is published continuously and publicly, it is worth understanding why anyone bothers tracking a motion this small in the first place. The wobble moves the poles by a few meters. That sounds like nothing until you consider what depends on knowing exactly where the axis is. Every satellite orbit is computed in a reference frame anchored to the stars. Every position on the ground is expressed in a frame anchored to the rotating Earth. Converting between those two frames, which is what a positioning system does thousands of times a second, requires knowing precisely how the rotating frame is currently oriented, including the wobble. Get that wrong, and errors propagate straight into orbit determination, into deep space navigation, into the timing corrections that keep global positioning accurate. A wobble that changes character without warning is not a curiosity to the people who maintain those systems. It is an input that stopped behaving. Now here is where this thread turns from planetary physics into something much closer to home. If moving water around can dampen the wobble of a planet, then moving water around does other things too, and human beings move an extraordinary amount of water. Researchers studying decades of satellite data set out to model the observed drift of Earth's rotational pole, the slow, steady migration of the axis, distinct from the wobble around it. They included the obvious contributors, the flow of the mantle, melting ice sheets, the construction of dams, and the model did not match. It was off by a large and stubborn margin. Then they added groundwater. Between 1993 and 2010, human beings pumped an estimated 2,150 gigatons of water out of the ground, for drinking, for industry, and overwhelmingly for irrigation. That water did not stay underground. It ran into rivers, evaporated, fell elsewhere, and ultimately ended up redistributed into the oceans. When the researchers added that mass transfer to their model, the discrepancy closed. Without it, the model was off by about 78.5 centimeters of pole drift over that period, roughly 4.3 centimeters a year. Let me be precise about what that claim is and is not, because it gets mangled constantly. The pole is drifting by roughly 10 centimeters a year overall, and the largest single influence on that drift is the flow of the mantle. What the groundwater study established is that among everything else, human water extraction is the second largest contributor, and the largest of all the climate-related ones. Water pumped from the mid-latitudes matters most. Western North America and northwestern India in particular did most of the work. Picture a basketball spinning on a fingertip. Add a small weight to one spot, or take a small weight off another, and the ball begins to wobble differently. Earth works the same way, and we have been quietly adding and removing weights. One geophysicist not involved in the research called the discovery mind-boggling. The way this planet wobbles is being shaped, measurably, by our own activities. There is an odd kind of dignity in that, and also something faintly absurd. We have turned the spin of the Earth into an instrument. Polar motion is now sensitive enough to act as a scale, weighing how much water humanity has moved from one part of the globe to another, in places where measuring groundwater directly is essentially impossible. So the field is splitting. The core has turned around. The pole sprinted and braked. The day is short. The wobble stopped. Every one of those is an output of the same interior, and every one of them was found by pointing a new instrument at an old question. Which raises an obvious problem. All of those signals arrive rarely, or slowly, or only when a large enough earthquake happens to light up the interior. What if there were a signal that never stopped? A continuous transmission from the inside of this planet, running 24 hours a day, that we only noticed a few decades ago. There is one. Right now, underneath you, the ground is humming. Part 9. The note that never stops. The ground beneath you is vibrating right now, at a pitch you will never hear, and it has never once stopped. Scientists call it Earth's permanent free oscillations. Most people, including most of the researchers who study it, just call it the hum. The frequencies involved sit between roughly 2.9 and 4.5 MHz, which means a single cycle takes several minutes to complete. Human hearing bottoms out around 20 Hz. This is thousands of times lower than the deepest sound you have ever perceived. It is not a sound in any sense you could experience. It is the entire solid body of the planet flexing, very slightly, on repeat, forever. For most of the history of seismology, the assumption was that this only happened after something hit it. That assumption made sense. A very large earthquake genuinely does set the whole planet ringing. The Great Chilean earthquake of 1960 and the Sumatra earthquake of 2004 both made the Earth resonate for weeks afterward, in modes with names that read like organ stops, each one a specific way an elastic sphere can vibrate. Strike a bell and it rings down. Strike a planet hard enough and it does the same thing, just very slowly. Then, in the 1990s, seismologists doing careful noise analysis on quiet days found the ringing was still there. Not the decaying remnant of a big earthquake. A steady, continuous, ultra-low vibration present on days when nothing significant had shaken anywhere on Earth. By 1998 it was established. The hum is permanent. The planet is not a bell that rings and fades. It is a bell that never stops, even though nobody is striking it. It helps to understand what modes actually means here, because it is the reason the hum carries information at all. An elastic sphere can only vibrate in certain specific ways, determined by its size, its density, and how those properties change with depth. A guitar string does the same thing. It has a fundamental note and a series of overtones, and it cannot produce anything in between. The Earth is the same, except the string is a planet, and the overtones are shapes. The whole globe breathing in and out, the northern hemisphere swelling as the southern contracts, patterns dividing the sphere into segments like the sections of a peeled orange. Each of those patterns has its own precise frequency, and crucially those frequencies depend on what the planet is made of all the way down. Change the density of the core, or the thickness of a layer, and the notes shift. Which is why the hum is not a novelty, it is a measurement. Every one of those tones is a constraint on the internal structure of the Earth, available continuously, for free, to anyone with a sensitive enough instrument and enough patience to average out the noise. So what is hitting it? The leading explanation for decades has been the ocean. Not the waves you can see breaking on a beach, but the much longer, much slower swells beneath them. Infragravity waves, with wavelengths of kilometers, rolling across entire ocean basins. Where those waves interact with each other, and where they press on the continental shelf and the seafloor, they exert a constant, rhythmic, planet-wide push. Billions of soft fingers tapping on a drumhead that happens to be the crust of the Earth. Individually negligible. Collectively apparently enough to keep a planet ringing. For years that stayed a theory. And it stayed a theory for an irritating and very practical reason. Almost every seismometer capable of detecting the hum sat on dry land. 70% of this planet is ocean. If the source of the hum really is out there, in the deep water, then the entire body of evidence was being gathered in exactly the wrong places, like trying to establish that a radio station exists by measuring the signal only in the buildings furthest from the transmitter. The problem was never a lack of interest. It was that the ocean floor is a terrible place to measure very small vibrations. An instrument on the seabed gets rocked by bottom currents, which tilts it. It gets pressed on by the very infragravity waves you're trying to study, which flexes the sediment underneath it. It develops electronic glitches from sitting in cold salt water for a year. All of that noise is enormous compared to the hum, and it sits in the same frequency band. In 2017, a team finally solved it. They took broadband ocean bottom seismometers, deployed on the floor of the Indian Ocean east of Madagascar, and analysed 11 months of continuous records. Rather than hoping the noise would average out, they modelled it and removed it, subtracting the average signature of the instrument glitches, then using the relationship between the pressure sensor and the seismic channels to strip out the tilt and the seafloor flexing. When they had finished, the long-period noise floor on an instrument sitting kilometres underwater was as clean as a good station on land, and the hum was there. That was the first observation of Earth's permanent free oscillations on the ocean floor, and it closed the largest blind spot in the map. The planet rings everywhere, on land, and under 70% of its surface where nobody had ever properly listened. What it did not do was settle the argument. Researchers still disagree about the exact mechanism. Some favour wave-on-wave interaction in the open ocean, sending energy downward through the water column into the crust. Some favour waves interacting with the seafloor near coastlines and continental shelves. Some think the atmosphere contributes as well, with shifting pressure systems adding their own push to the mix. The likely answer is that all three are involved and the proportions change with season and location, which is a deeply unsatisfying answer, and also probably the correct one. Here is why any of this should matter to you. Everything we have discussed so far, the reversed flux at the core boundary, the structures called Tuzo and Jason, the inner core turning backward, was measured using earthquakes. And earthquakes are a terrible light source. They are rare, they're violent, they're unpredictable, and they only illuminate the paths that happen to run between where the quake was and where the seismometers are. It is like trying to map a dark warehouse with a camera flash that fires at random intervals from random positions. The hum is not a flash. The hum is a light that never goes out. If it can be fully decoded, if researchers can pin down where the energy enters and how it propagates, it becomes a permanent, always available signal for imaging the deep interior of this planet. The same interior that is currently doing all the things we have spent the last hour on. A seismologist at Columbia University put the whole situation in one sentence. The Earth, he said, is ringing like a bell all the time, and that constant ringing is not just background noise. Sometimes it carries a message. In 2018, seismometers on every continent picked up a hum that was not the ordinary one, and following it led to something that had not existed a year earlier. Part 10. The hum that was a volcano being born. On the 11th of November 2018, seismometers around the world recorded a signal that nobody could identify. It was a low, steady ringing at essentially a single frequency, and it travelled around the entire planet. It was picked up in Kenya, it was picked up in Chile, it reached Canada and Hawaii. Individual episodes lasted up to about 20 minutes, and over the following period more than 400 of them were catalogued. Normal earthquakes do not sound like that. An earthquake radiates a chaotic mess of frequencies all at once. Sharp, jagged, broadband, the seismic equivalent of a drum being struck. This was smooth, almost musical, a pure tone circling the earth, and it got stranger the closer anyone looked. Real earthquakes produce specific classes of body waves, the fast compressional P waves and the slower shear S waves, which are the waves people physically feel as a jolt. This event produced almost none of them. No shaking, no damage, no emergency. Just a long, low ringing sweeping silently through solid rock, all the way around a planet, with essentially nobody on the surface aware it was happening. The source traced back to a small island in the Indian Ocean, between Madagascar and Mozambique, called Mayotte. The people who lived there already knew something was wrong. For months beforehand, the island had been shaken by more than 1,000 small earthquakes, almost daily, including the strongest quake ever recorded in that region. Residents were frightened enough that some of them stopped sleeping indoors and slept out in open ground instead. Scientists scrambled. Early theories pointed to a magma chamber draining somewhere beneath the seafloor, which was a reasonable guess and impossible to confirm because there was almost no local monitoring equipment anywhere near the island. Researchers were reconstructing an event from seismic stations thousands of kilometers away. It is the geophysical version of diagnosing an illness from the echoes bouncing off distant walls. So in 2019 they went and looked. A French research campaign sailed to the waters east of Mayotte aboard the vessel Marion Dufresne, led by a marine geoscientist at the National Research Centre. Between February and May of that year, the expedition's instruments recorded on the order of 17,000 seismic events, originating between 20 and 50 kilometres below the seafloor, a column of activity extending down into the upper mantle, and then the ship's echo sounder mapped the seabed. There was a volcano on it, roughly 800 metres tall, which is about half a mile, taller than the Empire State Building, several kilometres wide at the base, sitting on a stretch of ocean floor that had been surveyed before and had contained nothing of the kind. It had grown from nothing, entirely underwater, in under a year. It was later named Fanny Moray. The full reconstruction took time, and it is worth walking through because the mechanism is the whole point. Deep beneath the island sat a large reservoir of molten rock in the upper mantle, on the order of 15 kilometres across. Sometime in 2018, that magma began moving upward, forcing its way through kilometres of solid crust toward the seafloor. As it went, it fractured rock along its path, thousands of small failures, each one registering at the surface as a tiny earthquake. That is what the residents of Mayotte were feeling every day for months. Not a volcano erupting, a volcano arriving, grinding its way up through the crust like a drill bit, one tremor at a time. Then the magma broke through. The eruption that followed was extraordinary in scale. At least 6.5 cubic kilometres of magma were extruded onto the seafloor, which makes it the largest submarine eruption ever monitored by science, and one of the largest outpourings of lava anywhere on Earth since the Laki eruption in Iceland in 1783. And as that enormous reservoir drained, the cavity it was emptying out of resonated, the way blowing across the mouth of a bottle produces a single clean tone that depends on the size of the space inside. That resonance is what those seismometers in Kenya and Chile and Hawaii recorded, a pure note produced by a magma chamber the size of a city being emptied, ringing through the whole planet. An earthquake specialist who was not involved in the discovery made the observation that stays with me. He said that without that strange hum, scientists probably would never have found the volcano at all. Stop and turn that over for a moment. A mountain taller than a skyscraper was constructed on this planet in under a year. It happened roughly 50 kilometres from an inhabited island with an airport and a population of 250,000 people, and the only reason anybody on Earth knows it happened is that the entire planet rang like a bell to announce it, and somebody was listening carefully enough to ask why. This is what makes the hums worth taking seriously, and it is the reason this section is not a digression from the rest of the story. Sometimes the noise is just noise that we cannot fully explain. Sometimes it is the sound of the planet building something new underneath us in real time, and the only difference between those two cases is whether anyone bothered to chase the signal. We chased that one because it was strange enough to be undeniable. The question that keeps me up is how many signals we have written off as noise because they were not quite strange enough. And there is one more hum in this story. It is not the planet. It is much smaller, much more local, and for the people who experience it, considerably harder to live with. Part 11. The sound only. Some people hear. In towns scattered across the world, a small number of people report hearing something that nobody standing beside them can hear. They describe it consistently, a deep, constant droning or humming, low in pitch, usually worse indoors, worse at night, worse when everything else is quiet. It has different names depending on where you are. In New Mexico it is the Taos hum. In New Zealand it is the Auckland hum. Near the Canadian border with Detroit it is the Windsor hum. Reports have come from Canada, Australia, South Africa, Norway, and cities across Europe. A Canadian teacher eventually built an online database purely to collect the accounts, and it now holds thousands of entries from people convinced they are hearing something real. The estimates run between 2 and 4% of the population. Put 200 people in a school gymnasium and as many as 8 of them might swear there is a sound in the room that the other 192 cannot detect at all. For years, researchers chased 2 possibilities. The first was straightforward. Maybe hearers simply have unusually sensitive ears at low frequencies, picking up real sound in the 30 to 80 Hz range that everyone else's hearing filters out as irrelevant. There is a lot of low-frequency noise in a modern environment. Industrial plant, ventilation, traffic, distant machinery. And if a small fraction of people could hear a bit further down the scale than the rest of us, that would explain it neatly. The second was equally reasonable. Maybe there is a genuine physical source out there, something environmental or mechanical, that nobody has managed to locate. Investigations have been run in several affected towns. Some have found candidate sources, most have not. A study published in March of 2026 tested both ideas directly, with participants in Germany who experienced the phenomenon. It also tested a third and more interesting possibility. Deep inside your inner ear sits a small spiral structure called the cochlea, and the cochlea does not merely receive sound. It actively amplifies it, and as a byproduct of that amplification, it generates faint sounds of its own, which can be measured with a sensitive microphone in the ear canal. These are called spontaneous otoacoustic emissions, and most people who have them never notice. The obvious hypothesis is that hearers are perceiving their own emissions. The study found that they are not. Most participants did not show exceptional low-frequency hearing on standard testing, and their otoacoustic emissions did not account for what they were experiencing either. Both of the tidy explanations failed. What the evidence increasingly points toward is something generated further along the system, a rare, low-frequency form of subjective tinnitus, produced inside the auditory pathway but perceived as arriving from outside the body. Familiar tinnitus is the high-pitched ringing you get after a loud concert. This variant presents as a deep hum or a vibration, which is precisely why it feels environmental rather than internal. Imagine standing in a perfectly silent room and hearing a faint ringing that will not fade. Now imagine that instead of a ring, it is a low idling drone, and instead of fading over a few hours, it does not fade at all, and every instinct your brain has tells you it is coming from a truck outside or a factory or something underground. I want to be careful here, because this is where a lot of coverage of this subject goes wrong. Saying the sound is generated internally does not mean the people hearing it are imagining anything. The perception is real. The distress is real. Chronic low-frequency tinnitus interferes with sleep and concentration in exactly the way you would expect a sound that never stops to interfere with them. The scientific question is where the signal originates, not whether the experience is genuine. There is a detail in the pattern of reports that has always bothered investigators, and it cuts both ways. Hearers overwhelmingly describe the sound as worse indoors. On the environmental source hypothesis, that makes sense. Buildings act as low-pass filters, blocking high frequencies while letting the deepest ones through, and rooms have resonances that amplify particular low notes in particular corners. But the same observation fits the internal explanation just as well, because indoors at night is simply when the external noise floor drops far enough for a faint internal signal to become audible. Two opposite explanations predicting the same observation is exactly the kind of thing that keeps a question open for 50 years, and researchers are open about how much they still do not know. Hearing science has overwhelmingly concentrated on the frequencies we use for speech and music, because that is where the clinical need is. The deep end of the spectrum below where most audiometry bothers to test remains genuinely underexplored territory. So here we are with two hums, sharing a word and almost nothing else. One is an entire planet resonating at frequencies no ear could ever reach, produced by ocean waves and still not fully explained. The other is a sound with no external source at all, produced somewhere inside a structure smaller than a fingernail, and also still not fully explained. Two open problems that sound identical from the outside and have nothing to do with each other. We have spent this whole video listening to the inside of this planet from a distance, inferring, measuring, reconstructing. Which raises the obvious question. What happens when we stop listening from a distance and actually go down there and look? The answer, it turns out, is that we find things alive. Part 12. The lake that has been sealed for 15 million years. Beneath more than 2 miles of solid ice in East Antarctica, there is a lake roughly the size of Lake Ontario, and no sunlight has touched it since long before our species existed. It is called Lake Vostok. The ice above it is about 3.7 kilometers thick, around 2 1/3 miles, roughly the height of 7 Empire State Buildings stacked one on top of another. Beneath that ice is liquid water, held above freezing by the pressure of everything on top of it, and by heat rising from the rock below. No air exchange, no light, no contact with the atmosphere of this planet for an estimated 15 million years, and possibly considerably longer. 15 million years ago, there were no humans, no hominins of any kind. The Antarctic ice sheet was in the process of becoming permanent. Whatever was living in that water when the roof closed has been on its own ever since. We found it the same way we found everything else in this video, indirectly. In the 1990s, ice-penetrating radar surveys revealed a flat mirror-smooth reflector deep beneath the Russian research station at Vostok, flat in a way that ice simply does not get, and reflective in a way that only a liquid surface produces. It was the same trick a doctor uses with an ultrasound, seeing inside something without cutting it open. The confirmation was published in 1996. Detecting it and reaching it were completely different problems. A Russian drilling program took more than 2 decades to get through. The engineering constraint was brutal. Drill through more than 2 miles of ice in one of the coldest and most remote environments on the surface of this planet, without contaminating an untouched ecosystem underneath. Progress ran at a few hundred meters per season. The program ran so long that the ice cores brought up along the way became a major scientific result in their own right, preserving a record of this planet's atmosphere in trapped air bubbles stretching back more than 400,000 years, one of the foundational datasets in modern climate science, produced almost as a side effect of trying to reach the water underneath. They finally broke through on the 5th of February 2012, and then the lake did something nobody could do anything about. The water beneath was under such enormous pressure that when the drill punched into it, it surged up the borehole and froze solid before any instrument could be lowered down. The team had to wait for the following season and analyse that frozen plug of accreted lake water instead of sampling the lake directly. What came out of the analysis was thousands of distinct biological sequences, on the order of 3,500 unique gene sequences in the published work. The overwhelming majority were bacterial. There were additional signatures attributed to more complex organisms, and there were sequences related to species typically associated with deep-sea hydrothermal vents, which is a genuinely provocative finding because it hints that there may be a heat source at the bottom of Lake Vostok, something keeping that water liquid from below rather than merely insulated from above. Now, the honest caveat, because it has been part of this story since the day the results were published. Drilling fluid contamination is a live and serious methodological criticism of the Vostok results. Getting a clean sample from the bottom of a 2-mile borehole that has been filled with kerosene and antifreeze for 20 years is extraordinarily difficult, and not everyone accepts that the sequences recovered represent lake life rather than the drilling operation itself. The finding is real, and it is contested at the same time, which is an uncomfortable place to leave a story and the accurate one. It is worth pausing on how strange the physical setting actually is, because it explains why the water is liquid at all. Ice is a good insulator. Pile nearly 4 kilometers of it on top of a rock surface, and the heat leaking out of the earth beneath, the same heat that has been escaping the interior since the planet formed, gets trapped rather than radiated away. At the same time, the sheer weight of the ice above lowers the freezing point of the water underneath, in the same way that pressure lets a skate blade glide on a film of meltwater. Between those two effects, a lake at the bottom of an ice sheet is not an anomaly. It is close to inevitable, given enough ice, which is why Vostok turned out not to be alone. Once researchers knew what the radar signature looked like, they went back through the surveys and found more. Hundreds of subglacial lakes are now catalogued beneath the Antarctic ice sheet, some connected by channels that fill and empty over years, shifting enough water to be detected by satellites measuring the height of the surface above. There is a hydrological system down there, rivers and lakes and floods running in complete darkness beneath a continent on a schedule nobody knew existed 30 years ago. How life got in there is also unresolved. The leading idea is the simplest. Life was already present before the lake was sealed, back when parts of the region were exposed to open air, and it adapted generation after generation as the ice closed overhead. An ordinary ecosystem slowly rebuilt for permanent darkness. And this is not just a curiosity about one Antarctic lake, which is why serious money and 20 years of effort went into reaching it. Vostok is the closest analogue on this planet to the ice-covered oceans believed to exist beneath the frozen crusts of Europa, one of Jupiter's moons, and Enceladus, one of Saturn's. If life persists for millions of years in permanent darkness under kilometres of ice here, then the argument that it could not do so there becomes much harder to make. A scientist on the drilling expedition described it as exploring another planet, except this one happens to be our own. Life surviving in one of the darkest, most crushed, most isolated environments on Earth is remarkable on its own. It is also not the most extreme case. Because when researchers went looking beneath the seafloor, they found something that makes a sealed Antarctic lake look positively hospitable, and there is far, far more of it than anyone expected. Part 13. The larger half of life. On Earth. Underneath the ocean floor, buried in layers of ancient mud, there are organisms so starved of energy that some of them may only reproduce once every few thousand years. Set that against something familiar. The bacteria in your gut can double their entire population in about 20 minutes. Now imagine an organism where a single generation, from the moment a cell forms to the moment it divides, could stretch longer than the entire span of recorded human history. Researchers studying sediment drilled from the deep sea floor have calculated average generation times for some of these communities in the thousands of years, and in the most energy-starved layers, potentially far longer than that. Some researchers describe this state as physiological standby. The cells appear technically alive, they can carry out basic maintenance and repair, but they function at such an extremely reduced rate that the traditional definitions of growth and reproduction barely apply to them. One published assessment put it plainly: this kind of longevity is such a strange property that it is genuinely difficult to reconcile with our basic understanding of how life is supposed to work. Picture a marathon runner permitted one single step every few hundred years, never sprinting, barely moving, never collapsing either. The obvious question is what they are eating, and the answer is that mostly they are not. Down there, conditions are severe in a way that is hard to convey. No sunlight has ever reached this deep, so nothing is being made fresh. The food supply consists of scraps of organic material that drifted down from the surface ocean over millions of years and got buried under layer after layer of sediment. Every year that passes, the easily digestible fraction of that material gets a little more depleted, and what remains gets a little harder to metabolize. These organisms are living on the crumbs left by an ecosystem that died before the first dinosaur. Some of them are not living on organic material at all. In deep continental rock, microbial communities have been found running on hydrogen produced when water reacts with certain minerals, or on chemical energy released by the decay of radioactive elements in the surrounding stone. That is a food chain with no connection to the sun whatsoever, an ecosystem powered by geology and radioactivity, which is precisely the kind of system that could, in principle, run inside a planet with no surface habitability at all. And this is not a fringe habitat. It is one of the largest ecosystems on this planet. An international program spent 10 years trying to measure it properly. Teams drilled more than 1.5 miles into the seafloor. They sampled mines and boreholes kilometers deep on land. They synthesized data from hundreds of sites scattered across the globe. And in December of 2018 they announced the result, which stunned the researchers involved as much as anyone. Between 15 and 23 billion tons of carbon, locked inside living cells, buried beneath the surface of the Earth. To put that in scale, the combined carbon mass of every human being alive adds up to roughly 1/10 billion tons, which means this hidden layer of buried life outweighs all of humanity by somewhere between 245 and 385 times over. Picture all 8 billion of us on one side of an enormous scale. On the other side, bacteria and archaea pulled from kilometers beneath the ocean floor and from deep continental rock. That second side crashes down instantly. The habitat volume is estimated at roughly 2 billion cubic kilometers, on the order of twice the volume of every ocean on Earth combined. Something like 70% of this planet's bacteria and archaea live down there rather than up here. Confirmed life has been recovered from around 5 kilometers beneath the continental surface and around 10.5 kilometers below the ocean surface, under pressures on the order of 400 times what you experience standing at sea level. Down there, life does not look like life up here. Many of these organisms survive at such a crawling pace that researchers have taken to describing them as barely alive, existing in a strange in-between state, technically living, operating slowly enough to make a sloth look frantic. One of the researchers involved compared exploring Earth's deep subsurface to exploring the Amazon rainforest, an entire ecosystem full of species and behaviors we are only beginning to understand, except this rainforest is buried under kilometers of solid rock instead of standing in sunlight. Then there is the opposite extreme, which arrived as a genuine surprise. In certain deep, extremely hot regions beneath the seafloor, temperatures climb past 120 degrees Celsius, roughly 250 degrees Fahrenheit. Those are conditions researchers had assumed would sterilize buried sediment completely. Instead, drilling found active microbial communities living there too, and these are not the slow ones. They run their metabolism at rates similar to organisms living on the surface, apparently spending almost all of that energy repairing the constant molecular damage the heat inflicts on them. So beneath the seafloor, life exists at two opposite extremes at once. In the cold, energy-starved layers, organisms creeping along so slowly that their next reproduction might not occur in your lifetime or your grandchildren's. In the hottest, most crushed layers, Other organisms burning through energy at near normal speed purely to survive being cooked from below. Nobody fully understands how either extreme is biologically possible, and there is one more result from that work that quietly reorders how you should think about life on this planet. Researchers studying the deep history of Earth's biomass now believe that for roughly half the entire span of life's existence here, stretching back well over 1 billion years, the deep-buried biosphere outweighed everything living on the surface by as much as 10 to 1. Surface life as the dominant form on this planet, the plants, the animals, eventually us, is a relatively recent development in a much longer story. It changes the calculation for other worlds too. If an entire biosphere can persist for billions of years buried in total darkness, cut off from sunlight, inside a single rocky planet, then similar buried ecosystems could plausibly exist inside other worlds, beneath the surface of Mars, or sealed inside the icy shells of distant moons. We have spent decades scanning other planets for surface habitability, and the largest habitat on our own planet turns out to be the part with no surface at all. There is a second biosphere down there, invisible, outweighing us by hundreds of times, and it has been running alongside ours the entire time. And buried life is not the only thing hidden in the rock beneath your feet. Some of what is down there is not alive at all, and one particular discovery rewrote what we thought we knew about where the water on this planet actually is. Part 14. The ocean locked inside a rock. 400 miles beneath your feet, sealed inside solid rock, there may be as much water as every ocean on the surface combined. That sounds impossible on its face. Rock and water do not mix like that, and this is not water sitting in some hidden underground cavern, sloshing around like a lake in a cave. It is water bound at the molecular level, locked into the crystal structure of a mineral called ringwoodite, which forms only under crushing pressure and temperatures well over 1,000 degrees Celsius. Here is how we found out, and the chain of luck involved is almost absurd. Diamonds form deep in the mantle and are carried to the surface by violent, fast-moving volcanic eruptions. They come up so fast that whatever was trapped inside them at depth has no time to change. A diamond is a pressure vessel that survives its own journey, a fly in amber, except the amber is the hardest natural substance we know of, and the fly is a fragment of a place no human will ever visit. A diamond recovered from the Huina area of Mato Grosso in Brazil was found in 2008 and analysed over the following years. It was not a gem-quality stone. Commercially, it was almost worthless. Inside it, researchers found a microscopic inclusion of ringwoodite, the first sample of that mineral ever recovered from the Earth, rather than from a meteorite or a laboratory press. Ringwoodite only forms in a specific band of the mantle, between roughly 410 and 660 kilometres down, which geologists call the transition zone. Above that band, the same chemistry takes a different crystal form. Below it, another. So the inclusion carried its own address. It could not have come from anywhere else. When the team analysed it, about 1.5% of its weight was water, not liquid. Hydrogen and oxygen atoms locked directly into the mineral's molecular framework. The results were published in the journal Nature in 2014, and the geochemist who led the work described it as confirming that a massive amount of water is trapped in a distinct layer deep inside our planet. Picture a sponge squeezed under enormous pressure, holding water not as droplets you could wring out, but as part of the material itself, invisible unless you break it down at the molecular level. That is roughly the situation 400 miles beneath the surface. The obvious objection came immediately. One diamond is one diamond. That inclusion could have been a local pocket, a fluke, a wet spot in an otherwise dry layer, and it would prove nothing about the transition zone as a whole. That objection is correct, and it is exactly the right thing for a scientist to say. Then a second water-bearing sample turned up, trapped inside a different diamond. One mineral physicist involved explained the significance about as clearly as it can be put. One sample could just be a local anomaly, but a second sample means this is likely widespread across the deep Earth rather than confined to one small spot. And if the transition zone is hydrous at even about 1% by weight globally, the arithmetic gets extraordinary. Calculations suggest the total comes to something like 3 times the volume of every ocean on this planet's surface, combined. All of it locked invisibly inside solid rock, never touching sunlight, never forming a wave, never once reaching the surface as anything resembling the water you can swim in. There is a consequence of that arithmetic that goes well beyond trivia, and it concerns the rest of this video directly. Water changes rock. Even small amounts of water bound into mantle minerals lower their melting point and reduce their strength, which makes them flow more easily. A wet transition zone convects differently from a dry one. It generates melt in different places. It changes how easily slabs sink and how easily plumes rise, which means it feeds directly into the pattern of convection that eventually reaches the core mantle boundary, where Tuzo and Jason sit, where the reversed flux patches form, where the magnetic field of this planet is decided. The hidden ocean is not a separate curiosity from the hole in the shield. It is a parameter in the same machine. Where did it come from? The leading answer ties back to the machinery we have already discussed. Subduction drags slabs of old ocean floor down into the mantle over tens of millions of years, and those slabs carry water with them. Chemically bound in hydrated minerals rather than as free liquid, down it goes, deeper and deeper, until the minerals break down and hand their water off to whatever is stable at that depth. Researchers describe the transition zone almost as a graveyard for old ocean crust, quietly recycling surface water into the depths of the planet on timescales far longer than human history. So the water you drink is on loan from a cycle that runs through the mantle. Some of the ocean has been down there since before there were continents in their current arrangement. Some of it will be down there long after. And this is the thing about the deep earth that I keep circling back to. Every time an instrument gets sensitive enough, or a sample lucky enough, to give us a direct look at what is down there, the answer is larger and stranger than the models allowed for, a structure the size of a continent that we cannot identify, a core turning the wrong way, a biosphere that outweighs us hundreds of times over, an ocean inside a rock, none of which requires you to look up or out or anywhere but down. But there are things happening at the surface too, and above it, that are just as unresolved. Some of them are underneath entire cities. Some of them are floating through thunderstorms, breaking rules that physicists thought they had settled a century ago. Part 15. The ground is not a floor. Scattered across the ocean floor under crushing pressure and near freezing cold, there is a substance that looks like packed snow, feels solid in your hand, and burns if you hold a lit match to it. It is called methane hydrate. People sometimes call it fire ice, which is one of those rare nicknames that is both accurate and better than the technical term. It forms when methane gas gets trapped inside a cage of frozen water molecules, squeezed together under a very specific combination of intense pressure and low temperature, conditions found in deep marine sediment and beneath Arctic permafrost. Bring a sample up to the surface and it does something that looks unnatural. It fizzes, it sweats gas, and that gas ignites from a spark. The numbers are what make it significant. A single cubic meter of this material, roughly the size of a washing machine, can release up to about 160 cubic meters of methane gas once the cage breaks down. That is enough gas to fill a small house from floor to ceiling, packed inside a block barely bigger than an appliance. Estimates suggest that, combined, these frozen deposits scattered across ocean floors and buried under Arctic permafrost may hold more carbon than every reserve of coal, oil and natural gas on Earth put together. I want to flag that carefully, because it gets quoted as a hard fact and it is not. Hydrate inventory estimates have an enormous spread and have been revised downward repeatedly as sampling improved. What is not in dispute is that this is one of the largest carbon reservoirs on the planet, sitting almost entirely unmonitored beneath the waves. Here is why researchers watch it. These deposits stay locked and stable only within a narrow window of cold and pressure. As bottom waters slowly warm, some of that window closes, and the hydrates at the edges begin to dissociate. Picture the ocean floor as an enormous frozen pantry, shelf after shelf of sealed jars, each one held shut by cold and pressure. As the room warms, some of the lids loosen. The question that actually keeps scientists up at night is not whether the lids can loosen. It is how many loosen at once, and how much of what spills out ever makes it up through kilometres of ocean water to reach the atmosphere. That last part turns out to be the tricky bit, and the news there is genuinely reassuring. Researchers studying active methane plumes rising from the seafloor have found that most of the escaping gas dissolves into the water column and gets consumed by microbes long before it reaches the surface. There is a whole community of organisms down there whose entire livelihood is eating methane, and they are efficient. The complication came from work off the coast of West Africa, which found methane migrating more than 25 miles sideways underground before breaking through the seafloor in a completely different location from where it started, which means these systems do not behave in the simple, vertical, predictable pattern the models originally assumed. The geologist who led that research put it directly: far larger volumes of methane may end up released from these deposits than anyone previously assumed, and researchers need to dig deeper into what role these frozen stores actually play. So one of the largest and least understood carbon reservoirs on Earth is frozen solid across nearly every ocean, and its future behaviour is uncertain even to the people studying it most closely. And these deposits are not only found at the bottom of the sea. In the Arctic, similar buried gas has already started breaking loose on land. When it does not leak quietly. In July of 2014, a helicopter crew flying over Russia's Yamal Peninsula spotted something that should not have been there. A crater blasted straight into the frozen tundra, over 200 feet across, with no meteor, no reported explosion, no obvious cause at all. Just a violent hole punched into the ground in one of the most remote landscapes on this planet. Since then, researchers have identified around 8 of these giant craters scattered across Yamal and the neighbouring Gidan Peninsula, some of them tens of metres deep, and it turned out the phenomenon was not new to the people who live there. Local reindeer herders and gas workers had reported hearing unexplained blasts echoing across the tundra for years before anyone from outside confirmed what was causing them. Now here is the detail that kept the problem unsolved for a decade. This appears to happen only in this one specific corner of the Arctic. Nothing comparable in Canada, nothing in Alaska, nothing anywhere else across the entire circumpolar north, despite permafrost covering vast stretches of several continents. That single geographic fact ruled out simple surface warming as a sufficient explanation, because surface warming is happening everywhere and the craters are not. Something specific to this one region had to be involved, and in 2024 a study finally identified it. The mechanism is a chain. Beneath Yamal's permafrost, ancient marine sediment froze solid tens of thousands of years ago, trapping methane underground. Below that frozen layer sit natural gas accumulations, and heat rising from them slowly thaws the permafrost from beneath, even as surface warming thaws it from above. That leaves a pocket of highly pressurized gas squeezed between a thinning ceiling of ice and rising heat below. The missing piece was what turns a slow squeeze into a detonation. This region contains cryopegs, lenses of unfrozen extremely salty water trapped inside the permafrost, kept liquid by their own salinity. As the surface layer thaws, meltwater migrates downward and encounters that brine. Because the salt concentrations are so different, osmosis takes over. Fresh water is drawn toward the salt with real force, and pressure at depth spikes. That spike cracks the remaining frozen ceiling. The fracture causes an abrupt pressure drop underneath. And a sudden pressure drop is exactly what destabilizes methane hydrate. So the hydrates below flash into gas all at once, and the whole thing goes off, blasting a crater upward through solid frozen ground. The geographic specificity is explained by the combination. You need the frozen marine sediment and the gas beneath it, and the cryopegs, all in the same place. Yamal has all 3. One of the researchers who worked on solving it framed the contribution precisely. It was already known that something was breaking down the frozen methane layer underground. What the work finally showed was the exact physical trigger that turns a slow breakdown into an explosion. This is not a one-off either. Expeditions to one particularly dramatic crater, formed in a blowout on the 28th of June 2017, reconstructed roughly 3.5 years of gas pressure building in a mound beforehand. And when it finally went, witnesses reported flames shooting from the newly formed hole. Scientists suspect there are more of these than anyone has catalogued, because craters that filled back in with water and sediment before a pilot happened to fly over would never have been counted. Ground failing without warning is not confined to the Arctic, though. On a September morning in 2025, outside a hospital in Bangkok, a street simply stopped existing. Just after 7 in the morning, a stretch of road collapsed with no warning, swallowing an area roughly the size of a football field. A police tow truck went into the hole along with several other vehicles. Nearby buildings were evacuated while engineers checked whether the ground under them was still there. Officials estimated repairs would take at least a year, and within days the collapsed area had already widened as more ground gave way. Roughly a year earlier in Kuala Lumpur, a sinkhole opened directly beneath a sidewalk on a busy street, and a woman walking past in that exact moment disappeared into it before anyone could react. Sinkholes look from the outside like the ground deciding to vanish. The mechanics underneath are slow, physical, and reasonably well understood. Most form because water dissolves soft underground rock, limestone, gypsum, salt, carving out hidden cavities over months or years. Eventually the thin layer of soil or pavement roofing that space cannot support its own weight, and it drops. In the Bangkok case, investigators traced the trigger to soil flowing into a subway tunnel under construction nearby, made worse by heavy monsoon rain and by cracks forming in the tunnel structure itself. Think of a sturdy wooden floor above a basement that is quietly hollowing out. For years, nothing on the floor looks any different. Underneath, the supports are being dissolved or washed away. The floor holds right up until the exact moment it does not. What makes the recent cases unsettling to engineers is the location. Sinkholes have long been associated with regions known for soluble, porous bedrock. When a hole this size opens in the middle of a major capital city, outside a functioning hospital, in a spot with no prior history of collapse, it forces a harder question about how thoroughly anyone actually knows what is under their own streets. The tools exist. Ground-penetrating radar, seismic survey, and satellite interferometry can detect surface movement of a few millimeters months before a visible collapse. What none of them can do is watch everywhere at once. And the ground beneath a modern city holds far more voids, tunnels, abandoned workings, and leaking pipes than anyone has ever fully mapped. The ground is not a flaw. It is the top layer of the same restless system we have been descending through this whole time, and it is the layer we build on. Now look up. Because the sky above a thunderstorm is doing things that physicists still cannot fully account for either. Part 16. What happens above the storm? A thunderstorm rolls over a neighbourhood. Rain is hammering the windows, lightning cracks overhead. And then, drifting silently through the air, a glowing ball of light appears out of nowhere. It floats. It hovers. Sometimes it passes straight through a closed window without shattering the glass. Then, a few seconds later, it is gone. Sometimes with a loud pop, sometimes without a sound at all. This is ball lightning, and people have been reporting it for centuries. It appears in pilot logs, in cockpit sightings, in house fire investigations, and in hundreds of documented accounts every year in the United States alone. After nearly 200 years of serious study, physicists still cannot fully explain what it is. The problem is not that it is bright. The problem is that it behaves nothing like lightning. Ordinary lightning is a branching streak of electrical discharge gone in a fraction of a second following a path of least resistance to the ground. Ball lightning is a compact glowing sphere, usually somewhere between the size of a golf ball and a beach ball, that hovers, drifts or rolls for several seconds and occasionally close to a minute before disappearing. Think of a soap bubble crossing a room, glowing from the inside like a filament, moving at walking pace, then popping without warning. Several details in the reports have wrecked most of the leading explanations. One proposal was that ball lightning is a pocket of hot glowing gas, essentially a small floating flame. But hot gas rises, and the majority of sightings describe an object drifting horizontally or hovering steady, not climbing like smoke. Another proposal was that it is a bubble of trapped plasma, ionized gas, the same state of matter that lights a neon sign, held together by intense microwave energy left over from a nearby strike. That explains several features nicely. It struggles badly with the reports of a glowing sphere passing through a solid pane of glass and leaving it undamaged. One physicist studying the problem put it about as bluntly as anyone has. He said the failure to explain ball lightning does not come down to small missing details. The basic size, the basic power output, the basic timing, and the way it passes through solid barriers have defeated essentially every model proposed so far. But there is one hard measurement, and it is a genuinely wonderful piece of scientific luck. In July of 2012, a team of Chinese researchers had spectrometers and high-speed cameras set up on the Qinghai Plateau in the northwest of the country, studying ordinary lightning. That region gets a lot of it. During a late-evening thunderstorm, immediately after a cloud-to-ground strike about 900 meters from their equipment, ball lightning appeared, inside their field of view, with the instruments already running. They captured the first optical spectrum of natural ball lightning ever recorded, published in the journal Physical Review Letters at the start of 2014. The spectrum contained emission lines from silicon, iron, and calcium. Those are the elements you would expect to find in soil, and they were present for the entire lifetime of the object, not just at the moment of formation. That result supports a specific hypothesis, that a lightning strike vaporizes silicates in the ground, that the resulting silicon vapor condenses into a network of nanoparticles, and that this network then oxidizes slowly in air, burning gently from the inside as it floats. It is a chemical explanation rather than an electromagnetic one, and it fits what the instruments actually saw. It does not close the case. It says nothing at all about the objects that reportedly pass through glass. But it is a measurement, and in a subject this cluttered with anecdote, a measurement is worth more than a dozen theories. Ball lightning is not the only glowing mystery around thunderstorms. Above the clouds, storms are launching something even stranger, straight up toward the edge of space, and almost nobody on the ground ever notices. In 1989, a team of scientists in Minnesota was testing a low-light camera intended for an upcoming rocket launch. They pointed it at the night sky, not expecting anything in particular, and accidentally filmed a massive reddish burst of light flickering above a distant thunderstorm, stretching upward, away from the ground, instead of down toward it. It lasted a fraction of a second. That was the first recorded sprite, and it turned out to be the first member of an entire hidden category of electrical activity that nobody had properly documented. Sprites do the opposite of what lightning is supposed to do. They erupt upward from the top of a thunderstorm, reaching into a layer of the atmosphere called the mesosphere, roughly 50 to 90 kilometers above the surface. That is higher than commercial aircraft fly, higher than weather balloons reach. It is the region where the atmosphere is thinning out into space. The whole event is often over in about 10 milliseconds, faster than a single blink. Visually, the best description is a jellyfish turned upside down, tendrils reaching upward, glowing red, then gone. Sprites are not alone up there. Scientists later documented blue jets, narrow columns of blue and violet light that shoot upward from storm tops at enormous speed, sometimes punching well into the stratosphere. Where a sprite flickers like a jellyfish, a blue jet looks more like a single beam fired straight up. For decades, these events were essentially mythical. Pilots had reported strange flashes above storms going back over a century. Without proof, most scientists dismissed the accounts as tricks of the eye or reflections off cloud. It took an accidental piece of camera footage, and then astronauts pointing specialized instruments down at Earth from the International Space Station to confirm the phenomena were real and to document them properly. That is part of what makes the discovery remarkable. We lived underneath these storms for the entire history of our species, and we only recently realized there was an entire light show happening directly above our heads, virtually every day, somewhere on this planet. And it is still not solved. Scientists cannot fully explain what makes one storm produce a sprite or a blue jet while another storm, apparently just as powerful, produces none at all. Researchers are also investigating whether these upper atmosphere flashes connect to gravity waves, ripples of energy that travel silently through the upper atmosphere, spreading like the rings from a stone dropped into a pond. What is clear is that these flashes are not decoration. They measurably affect the chemistry of the upper atmosphere, and understanding them better is expected to feed into aviation safety and storm forecasting. There is one more thing that came out of the sky recently and left a lot of people asking questions, and I want to close this section with it because of how the story ended. Across 23 days in March of 2026, an unusual number of large objects came through the atmosphere over the United States and Europe. It started on the 17th, over Cleveland, Ohio, with a rock roughly 2 meters across and around 7 tons in mass, entering at about 45,000 miles an hour. It broke apart high above the city and sent a sonic boom rolling across Ohio into Pennsylvania, rattling windows under a completely clear sky. 4 days later, it happened again over Houston, with a smaller object, about a ton, breaking up 29 miles up and releasing energy equivalent to roughly 26 tons of high explosive. A fragment went through the roof of a house in a Houston suburb. Before the month ended, there were more fireballs over California, Arizona, Nevada, Louisiana and southern Illinois, plus a daylight explosion over Western Europe that generated over 3,000 eyewitness reports on its own. The number that got attention was the reporting rate. March of 2026 averaged nearly 143 witness reports per event, against a next highest March, back in 2021, of under 50. Roughly 3 times normal in a month with no major meteor shower on the calendar. We covered the resolution of that in detail in our video from August 1st, so I will keep it brief. Every fireball with enough data to calculate a trajectory traced back to an ordinary orbit around the Sun. 2 recovered meteorites, one from Ohio, one from the European event, turned out to be chondrites linked to the asteroid Vesta. And the statistical work that followed found the overall counts consistent with the long-run pattern, once you account for how variable these numbers naturally are. The surge was largely in reporting, not in the sky, but one part of it was never fully explained, and it is worth remembering. Most fireballs are silent streaks, gone in a second, producing no sound at ground level whatsoever. In that month, 82.5% of the events produced audible sonic booms. That is a genuinely odd residue on an otherwise resolved story. And there was one more uncomfortable detail. When the Ohio object exploded, the region's dedicated all-sky meteor camera happened to be offline. Scientists had to reconstruct the entire event from scattered doorbell footage and phone video. In an age of satellites circling the planet continuously, our system for tracking what comes in still has real gaps in it. Which is the same lesson as everything else in this video, pointed upward instead of downward. What we detect is a function of what we happen to have switched on. Part 17. The models that keep being wrong. Coral reefs are supposed to follow a predictable script. The water gets too hot, heat stress builds, the coral expels the microscopic algae living inside its tissue, the algae that give it both its colour and most of its food. The reef turns bone white. Then, depending on how long the heat lasts, the coral either slowly takes its algae back and recovers, or it dies. That has been the working model for decades. Real reefs keep refusing to follow it. Reefs across the Indian Ocean, devastated by a massive global bleaching event in 1998, staged a significant wide-scale recovery over the following decades. Meanwhile, reefs in the Western Atlantic, hit by a string of smaller and far less dramatic bleaching events, kept declining anyway, worn down gradually rather than knocked flat. Same basic threat, opposite outcomes, and researchers are still working out why identical stress produces such different results, depending on where in the ocean you look. Picture 2 neighbourhoods hit by the same storm. One rebuilds within a few years, stronger than before. The other never quite recovers, worn down a little more by every smaller storm that follows. It gets stranger at smaller scales. Researchers studying reefs in northwestern Australia, in a region with some of the most extreme daily tidal swings on Earth, expected those corals to be unusually tough, because they already deal with wild temperature shifts every single day as the tide goes in and out. In some ways, that toughness held up, but coral sitting in the shallow tidal zone and coral sitting only slightly deeper, in water that barely differs in temperature, recovered from the exact same bleaching event on completely different timelines. A few feet of depth produced entirely different survival stories. Analysis of recovery across Australia's Great Barrier Reef found another twist. Nearly half of the severely damaged reefs studied did not recover along one smooth curve at all. They followed what researchers describe as a 2-phase pattern, an unpredictable pause or stall partway through recovery before resuming, if they resumed at all. Standard models built to predict reef recovery struggle to capture a pause like that, because they assume a steady curve, and layered on top of everything is a timing problem. The average gap between major bleaching events worldwide has shrunk to less than half of what it used to be. Reefs that once had decades to recover between major heat stress events now sometimes get a handful of years. It is like asking someone to fully heal from one injury while already bracing for the next, over and over, with the recovery window shrinking each time. Something similar happened in the open ocean, and it is happening again right now. In October of 2013, a strange pool of unusually warm water appeared off the coast of Alaska. Researchers nicknamed it the Blob. A persistent zone of high pressure settled over the northeastern Pacific and simply stayed there, month after month, weakening the winds that normally stir and cool the ocean surface. Without that stirring, heat that would usually get mixed away built up instead. By the summer of 2014, the warm water stretched over 1,000 miles, from Alaska down to Mexico, reaching as much as 7 degrees Fahrenheit above normal in places. It persisted for nearly 3 years. What made it scientifically strange is that researchers still genuinely debate what caused it, and more importantly, what caused it to last so long. Some studies point to broader ocean warming as the trigger for the atmospheric ridge. Other work suggests the ridge came first and drove the warming, with the two then reinforcing each other in a loop. The ecological consequences were brutal and fast. The small, lipid-rich crustaceans that fish and seabirds depend on nearly vanished from sampling nets off Oregon. In their place, researchers found pyrosomes, translucent, gelatinous, tube-shaped colonial animals that had never before been documented in those waters, competing directly with native species while offering far less nutritional value to anything trying to eat them. Sea lion pups washed ashore starving in unprecedented numbers. Thousands of seabirds died. Toxic algae blooms stretched unusually long, contaminating shellfish along the entire west coast and delaying commercial fishing seasons. Kelp forests were stripped bare as warming water triggered explosive growth in sea urchin populations, leaving behind what scientists now call urchin barrens, bare underwater landscapes that in some places still have not recovered. One research team, watching an ecosystem shift that fast, asked in print whether it had crossed a tipping point it might never fully return from, and here is the part that should give you pause. In 2026, ocean temperatures across that same stretch of Pacific climbed again. The National Oceanic and Atmospheric Administration is currently tracking marine heat waves in the Northeast Pacific, one of which reached roughly 10 million square kilometers, the largest Northeast Pacific marine heat wave since records began in 1982, with a second event developing offshore in May of this year. The forecast puts the likelihood of continued marine heatwave conditions off California and Baja California at somewhere between 70 and 100% through the end of the year, and between 30 and 70% off Oregon and Washington. Researchers have been explicit that conditions comparable to the original blob, or exceeding it, may be returning, while we still do not have a complete answer for why it happened the first time. I want to give you 2 quick cases where the models were wrong, in a way that resolved cleanly, because it is not all open questions. The first is in northern Canada. Stand in the right part of the Hudson Bay region, and you weigh very slightly less, because the actual pull of gravity there is measurably weaker than almost anywhere else on Earth. Gravity surveys in the 1960s found the dip and could not fully account for it. The obvious explanation was the Laurentide ice sheet, nearly 2.5 kilometers of ice that buried most of Canada and pressed the crust down beneath it like a mattress under a weight. The ice melted around 10,000 years ago, and the crust has been springing back ever since at about 1 centimeter a year, with roughly another 300,000 years to go before it fully recovers. Less crust in place means less mass, which means less gravity, except the arithmetic never quite closed. So researchers went looking for a second contributor, and satellite gravity measurements found it. Slow churning currents in the mantle actively dragging the crust down in the same region, working alongside the leftover dent rather than against it. The lingering effect of the ice sheet accounts for something like 1/4 to nearly half of the anomaly. Deep mantle convection supplies the rest. 2 answers, both correct, one from the recent icy past and one from the ongoing churn beneath. An ice age that ended before writing was invented is still altering the strength of gravity across a stretch of the modern world. The second case is Yellowstone, and it is the most recent of all of them. For decades, researchers pictured the magma system there as a single giant chamber, slowly filling with pressure like a balloon. In April of 2025, a team from 4 universities finally mapped the top of the reservoir in sharp detail, using a 53,000-pound vibroseas truck to send precisely controlled vibrations into the ground and more than 600 temporarily deployed seismometers to record the echoes. An ultrasound of a supervolcano. What they found was not a thinning, fragile ceiling about to crack. It was a sharp, gas-rich cap sitting roughly 2.5 miles down, actively holding the system in check. The upper reservoir turned out to be about 86% solid crystalline rock. The remaining 14% is pore space, roughly half molten material and half volatiles, including water, in a state so hot and pressurized that the line between liquid and gas essentially disappears. The system is venting gas steadily while staying stable, and pressures at the top of the reservoir were described as well below what would be needed to trigger an eruption. Solving that immediately opened another question. What was feeding the system in the first place? The standard picture was a narrow plume of superheated rock rising in a straight line from near the core, like a candle stuck up through the mantle. Newer work suggests something broader, a wide, sideways moving current of hot rock, pushed by the motion of tectonic plates above, generating magma much closer to the surface, distributed through a vast region of partially melted rock rather than one discrete chamber, which matters enormously for monitoring, because the existing instruments were designed to watch for a deep singular plume, and researchers are now adapting them to track something with a completely different shape. Two more quickly, because they make the same point in different centuries. There is a stretch of this planet's history so stubbornly uneventful that geologists nicknamed it the Boring Billion. From roughly 1.8 billion years ago to about 800 million years ago, a full quarter of Earth's existence, climate stabilized, oxygen levels flattened, and life persisted without major innovation. Then everything changed at once. Global glaciations, complex life, and eventually the Cambrian explosion around 520 million years ago. Why the long pause? One line of evidence points to unusually stagnant plate tectonics as Earth's interior cooled and the crust thickened. Another, from analysis of thousands of rock samples, found that dissolved trace metals in the ocean, copper, zinc, cobalt, the metal cells need for core biochemistry, dropped significantly during exactly that interval, suggesting life was starved of raw materials rather than simply idle. A third strand found early complex life appearing right at the start of the interval and then collapsing in diversity partway through, which suggests it was not boring at all, just badly recorded. Nobody has settled it. And then there is one from our own century, which is my favourite, because it is a case of science correcting a story that everybody loved. For years, the most beloved idea in popular forest ecology has been the wood wide web, trees connected underground by fungal networks, sharing food and warnings, nurturing their own seedlings, effectively communicating. It came from real research, a 1997 study demonstrating that carbon can move between trees through mycorrhizal connections, and it grew into best-selling books, documentaries and blockbuster films. Here is what the biology genuinely supports. Nearly every tree on Earth forms a real, well-documented partnership with fungi in and around its roots, trading sugars from photosynthesis, sometimes an enormous fraction of everything it makes, for water and nutrients pulled from the soil. Those fungal threads really do form sprawling networks connecting multiple trees, sometimes across species. Where it gets shaky is the leap from partnership to intention. A major review examining 28 separate field experiments testing these claims found only 5 that even hinted at nutrient transfer happening between trees at all, and not a single one that demonstrated an actual benefit to the seedlings supposedly receiving help. A separate analysis traced how the narrative itself drifted, finding that among papers published in 2022 citing the foundational research, fewer than half accurately represented what those original studies had shown. One researcher compared the pattern to a long game of telephone. The network is real. The evidence that trees are deliberately using it to communicate is not there yet. And notice that this is not a debunk of the underlying biology. It is a debunk of a story that outran it. Part 18, The Instrument Doing the Looking. Every mystery in this video has been outside of you, buried in rock, hidden in ice, floating above a storm, The strangest one might be sitting about 3 pounds worth behind your own eyes, running the entire time you've been listening. Neuroscience can map your brain in remarkable detail. It can trace which neurons fire when you see the colour red, which regions activate when you feel fear, which pathways light up when you recognise a familiar face. Modern research has gotten very good at the question of how thoughts form, how memories consolidate, how a signal travels from your retina to your cortex in a fraction of a second. Underneath all of that sits a question science still cannot answer. Why does any of it feel like something? A philosopher gave that question a name in 1995, calling it the hard problem of consciousness. The distinction is worth getting right. Researchers call the questions about brain mechanics the easy problems, not because they are simple, but because we understand the general shape of the approach that would eventually solve them, even if the details take another century. The hard problem is different in kind. It is not about mapping which neurons fire. It is about explaining why that firing is accompanied by an inner experience at all, instead of happening in the dark, like a machine running its program with nobody home to notice. Watch a firework explode. Science can fully explain the chemistry behind the colours, the physics of the explosion, the exact wavelength of light striking your eye. None of that chemistry explains why you experience the burst of red and gold as beautiful, why it is like something to witness it rather than simply registering as data. That gap has a name too. Philosophers call it qualia, the specific personal quality of an experience, the particular redness of red, the exact sourness of biting into a lemon. You can describe wavelengths and taste receptors in perfect detail and never once capture what it is like to be the one tasting. Dozens of competing theories try to bridge it, from accounts rooted entirely in brain biology to far more radical proposals that consciousness connects to something fundamental about the nature of reality itself. None has closed the gap. Some researchers openly wonder whether it can be closed with the tools science currently has, and that is where this whole story lands. Everything we have covered traces back to one uncomfortable, thrilling fact. This planet was never finished. It was never a solved object waiting for us to arrive and understand it. It has been changing the entire time, above us and beneath us, and in almost every case we noticed by accident. A camera left running during an equipment test caught the first sprite. A helicopter pilot glancing down at the right second found a crater that had exploded with no witnesses. A worthless diamond dug out of Brazilian soil for entirely unrelated reasons was quietly carrying proof of an ocean's worth of water, sealed inside rock. Instruments set up to study ordinary lightning happened to catch the one thing nobody could photograph. Which means the honest summary of the last decade is not that Earth has started behaving strangely. It is that we finally built enough sensors to notice what it has been doing all along. The rising count of strange things happening to this planet is, to a first approximation, a measurement of how many new instruments got switched on. And nothing on this list happened in isolation. Pull the thread at the top and something moves at the bottom. The crack in the magnetic shield traces down to reversed flux at the core boundary, which traces to a structure the size of a continent, which sits above a core doing something nobody predicted, which drives the pole now racing towards Siberia, which feeds the same navigation systems that also depend on a rotation rate that recently changed for reasons unknown. The ground hums, the water hides in stone, the reefs refuse every model. It is one restless connected system, and we are standing on top of it, mostly unaware of how much of it is shifting underneath us at any given moment. There is one thing I will be watching, and you can watch it too, because the data is published openly. The South Atlantic anomaly is split into two separate weak points, and the one over Africa is failing faster than the one over South America. If those two centres keep pulling apart, this is not ordinary secular variation, and the models we use to protect every satellite in low orbit are describing a field that no longer exists. If they merge back together, it was a fluctuation, and we can all relax. The next update to the global field model will tell us which. So the only real question left is the one we started with, turned around. Not what is wrong with Earth, but how long has all of this been happening quietly, underneath every generation that came before us and never had the instruments to hear it,